question?
Yeah, please, can you come back again, please? Let the question start now. Sorry, yeah.
Okay. How do we know a particular stage to go back and modify? That is, will the machine identify where the error comes from?
Okay, thank you very much. Thank you. Yeah, so for the question, how do we know what to go back? The questioner is referring to this, the iterative process of machine learning system development. Yeah, it's once we call performance measure. You see, this performance measure, when you start solving a problem, we have to define the performance measure before we start. For example, performance is going to be accuracy. If you are doing classification, we want to predict if a student is going to pass or fail. That is a classification problem. So we have accuracy. So we have also maybe the others like ROC, curve, and then the confusion matrix. We call something confusion matrix. We'll mention that also later when we talk about classification. Now, however, so once you do data modeling, then performance measure will come in. You check what is the accuracy. Oh, we are getting 60%. To some people, I've seen a situation whereby just getting 65, the industrial counterpart said it's enough. I said, we just started actually. We need to optimize. He said, no, it's enough. He said, what we used to get in our statistical method of predicting that problem used to be 20%, 30%, and it's okay. He said, this is 65. To me, it was too low, but he said, it's okay. So it depends on the area you're applying. But for medical, it has to do with human life. We want to get 100% if possible. So if I get 65 for medical application, I will go back. I know that, no, it's not yet enough. Then based on experience now, this is where experience comes. You remember I mentioned at the beginning, I gave a very vivid comparison here. I want us to always refer to it. I compare machine learning to this gardening. You see, I said seed is the algorithm. You have to use the appropriate seeds. If you run wrong seeds, which is a wrong algorithm, we will not get good results. Nutrient also is the data. The data must be clean. Gardener is, so it's like you get to your farm and the system is, you find out that your crop is not growing. There are a lot of questions that comes to your mind. What is responsible? Is the seed bad? Is the nutrient bad? So you need an expert now. This is where working closely with an expert, especially at the beginning, you might need a kind of a guide to push you through. Okay, this is what I'm facing. And that's what we do for some of our students, by the way. This is what we are facing, doctor. We have run our algorithm. This is what I say, okay, if that's the case, I ask them, let me see the data. Okay. If I see the data, I see the nature, I say, okay, based on this, go back to the algorithm first. Do the optimization of the parameter. Try to change the parameter of the algorithm. We talk about maybe later in the afternoon, inshallah. So based on that, based on my experience, people who have this kind of problem, no. Don't waste your time on optimization. It's not optimization. Go to your feature engineering. You have selected wrong feature. Sometimes you have selected data preprocessor. And sometimes, depending on the problem area, if you don't have an expert, you have to carry out all the procedures. You first go back to the algorithm, change them one after the other, do the optimization, yet it's not good. Go back to feature engineering. Maybe that's where the problem comes. It's not good, then go back to data. Maybe your data is dirty, by the way. It's not clean. We have to do that. I hope that's clarified the question. So it's not a particular rigid procedure, but you have to have the performance measure to check. If it is regression, we'll be looking at root mean square error. That's something we call root mean squared error that will tell you what is the error. This is the value to be predicted. The student in the past got 35.5 marks, but the system is predicting it to be 35.2. It's very close, but there's an error. We check the error. Root means the cumulative effort of all the data points. So I'm getting like 20-something as the error. Is it acceptable to me? You have to discuss with the client who you are working with, the people who owns the data. They know what they want. If they are not yet satisfied, then you have to keep going back. To know what to do at the appropriate time, you may have to consult experts until you become an expert that you also can decide what is wrong with this my model. I hope that clarifies. Thank you. Next.
Okay, thank you, Prof. The second question, can you explain more on overfitting and its difference with underfitting?
Okay, thank you very much. So, yeah, I explained it briefly. So, because we don't have the opportunity to do that. You see, overfitting means overfitting. You know, this machine learning cell is like you are fitting this data to a particular expectation. So we gave the data info this date, we gave it. So at the end of the day, when we check the learn model was generated, we check the performance, and it's saying, oh, we are getting 100%. We celebrate ordinarily, but then I say, don't celebrate yet. You only celebrate if the testing set is okay. Because the essence of training machine learning is to have a system that can work on what we have never seen before. See? So when you get 100% in training, we cannot declare it as overfitting. Not yet. We go to testing now. Unfortunately, during testing, when we gave out the testing, it was only able to get 25% accuracy. Can you imagine? The same model, now we brought the same model down here, but when we give a new sample that it has never seen before, it generated 25% accuracy. This is clear overfitting. It means the data actually memorized this data, by the way. That is called overfitting. It does it too much. You see, for regression, you can have it like this. We have a regression. These are regression points. These are points we want to draw regression. We draw it small like this. This is a good model. An overfitted model, we go through every point, try to get everything by force. So this is an overfit. It could be an overfitted model, this one. But this one that goes, although it doesn't get all the points right, but it's closer to all the points. You see, this is the idea. And that's why I mentioned that we can afford to let the system make some mistake. Instead of getting 100% here and getting 25% here, I want something that can get like 90% here and then get for me maybe 75% here. This is excellent. And I can now continue to update my system. Do I need to do more optimization? Do I change the algorithm so that I can increase it if 90% is not enough for my clients? But to get 100% or 99, or if you can even be 75% in the training, but during testing, is even getting 5%. It couldn't recognize a new data. That is the signal to know this is overfitting. But for underfitting, it's going to perform poorly on this one and perform poorly on this one. So I said the difference between overfitting and underfitting in a simple term is overfitting. It has poor performance during testing, but excellent performance during training. So it can deceive you. You train, you can celebrate. Oh, 100%. I say don't celebrate until you have checked the testing set. But for underfitting, it performs poorly for both training and testing. It means the algorithm doesn't understand the data. You try several things, you change the features, you clean the data, yet you are getting maybe 40% training set accuracy, 30% testing accuracy. Still very poor. This is called underfitting and overfitting. Hopefully that clarifies. And like I said, thank you very much. We always, there are other lectures where we discuss this thing in detail. Because of time, we cannot really do more than this. Thank you very much. Now.
Thanks, Prof. The third question is, kindly expatiate on the use of ML for drug discovery.
Okay. Thank you very much. Yeah. Since these are areas that medical team are really getting more involved in, actually. So, because drug discovery, you know, it's about trying to see which compound will work to attack a particular, maybe bacteria, or the medical team will know better. When you want to develop a drug, you want to target some system. which one will work better? What are the attributes of a particular chemical? If we mix it with another chemical, what does it produce? You see, in those days, people used to, and that was one of the systems they actually used during the so-called during the COVID-19 system, by the way. You see, usually it takes a lot of time, but with simulation, with ML, they can do a lot of predict system. If we have this chemical, we mix them together, this is going to produce. Based on historical data, so they are now able to make quick decisions, just like any other feed. Just any other feed are benefiting. So when you want to make a drug, for example, you want to know the kind of chemical proportion to be used. If I use the proportion also, how is it going to work on the target? Is it antibiotics or whatever you are targeting into to kill actually? So you look at the previous data and then try to say, okay, what will happen if I change a particular variable? If this particular if this particular chemical component is reduced in volume, what will be the effect on the drug? And so many other possible applications of AI in medicine, especially AI in drug discovery, is that one of the very top area that people are really very much interested in as they pump in a lot of money for people to investigate how to use AI to improve medicine. Thank you very much.
Thanks, Bob.
Yeah,
please, I would like to know more about ML application in satellite imagery analysis.
Okay. Yeah, just like I mentioned, for people who deal with imaging, there are so many application areas you can go down there. Depending on the kind of forms when satellite bring in image, we want to identify what is this image, by the way. So we train a lot of there are a lot of images that have been brought to us by satellite. We already know what are inside those images. We use those images to train our system. When these images are being collected new, we don't need to take it back to the laboratory, by the way. We already have a system that will tell us what is inside this image is this. And this is what they are using now in surveillance. You want to know an enemy is there. Who is that enemy? The moment you take the picture, because there are a lot of previous data that have been kept actually. So the advantage is that instead of taking your image back to the experts in the room who will spend another day trying to analyze, the system on the go can tell you this is what is happening, especially if you have trained them with high precision. And this is what is also going on in area of maybe medical imaging. You need an expert, when you take an X-ray, you need someone to sit down and analyze what is in this X-ray, this and that. You know, it takes time. They are human beings. Maybe it's during the weekend. They need to call her or him to come to the clinic. With a well-trained system of AI, to do the prediction, oh, this is what is happening to this patient, even before the doctor arrives actually. And this can be deployed in villages, especially with this is an area I think some of the challenging security situation could actually take advantage of such system, train enough system with previous data and try to predict what is in this image, so that to shorten the time. And sometimes also human interpreter might make mistake on the analysis of the image system. And that's why I mentioned the navigation on Mars. You know, a lot of things are going on there, where they send a lot of cameras, taking pictures, sending them back, and they keep analyzing and try to see what will happen. Thank you. Next.
Prof, I think it's already past 9. I don't know. Will I continue with the question?
Yeah, let's take more few questions. So that's
okay.
Yeah. So we are sorry for that.
5.
People want to leave that can take a leave already. You see the recording when we come back. Okay. Yeah, we can take the questions.
Okay.
Yeah.
What is outliers, and how can one solve problem related to it?
Outlier. Where outliers, they are when you have data sets, there are data that are out of range of your data. For example, I'm analyzing student data in my class, and I want to develop student predictive solution that can tell me a student that will likely fail my course in this semester. So I want to know so that we can concentrate more on that student, not because we want the student to fail, by the way. We want, if the system predict that this student might fail, based on historical data, we give that student more time, more concentration. We ask him a lot of questions, what are the challenges? And then we can be able to solve the problem. So let's see that I'm having such a data. So when I'm looking at the data of my student, there's age. Suddenly I found the column age that was 280 in the age. Every other student, 23, 24, 25, 20, 19, 23. This only one that is 280. Something must be wrong. This is known as outlier. This is an outlier. It's out of range. It's not supposed to be here, but now I have it in my data. What do? The best way is to go back to the source of the data to ask them to check. But often than not, the source is no more available. The person who did it already left. Maybe he was trying to type 28 and the keyboard mistakenly typed a 0 at the end. We ended up having 280. This thing happens a lot. This is called outlier. And if you don't treat the outlier, actually, it will confuse the learner. Because imagine when you plot this number on the number line, you see all the system will concentrate around here. Only this 280 will take us to this far. Imagine machine learning trying to understand these guys and also trying to understand this one. For sure, this can lead to a lot of confusion that we don't envisage. So when you have a data, that's why pre-processing, we identify if there's outlier. You can use a simple box plot. We call something box plot in Excel. Even simple Excel can do that for us. It will show you if there's outlier or not. Thank you.
Okay, thank you, Prof. What is the effect of ML on risk of depression in young adults?
Well, I think that's a very interesting research topic, by the way. So, what's the effect of machine learning? Or maybe the questioner want to ask, how can we apply machine learning? I hope I get the question right. Come again, doctor, what is the effect of
ML on risk of depression in young adults?
Okay, risk of depression. We can look at this question from two angles. Maybe somebody is want to ask, can machine learning cause depression for people? Generally, too much exposure to anything can cause depression for people. You have to get connected to your people. You have to interact with people. However, the positive side I want to look at the question is that it's trying to see, can we use it in that direction? Yeah, there are a lot of work that can be done in that area. This is one of the areas, like I said, prediction is not the only thing we do in ML, but a lot of problems falls into prediction, actually. Trying to know someone is having problem before it gets out of hand. A lot of people, like people used to say, a lot of people are going on the street, they are almost getting to a turning point in terms of sickness mentally, but no one knows. He himself, he doesn't know. He thought it's fine until he breaks down. Is there anything we can do to prevent this kind of breakdown? You see? So this is why sentiment analysis, one of my master students of recent, sentiment analysis, what they do was to analyze. They want to analyze social media to be able to predict if somebody is having mental problem. Because when you chat with your friend, you are likely to chat with normalcy, with free, because mental diagnosis is one of very challenging things to do. If you diagnose a mentally challenged someone, it can attack you. Even asking questions closer to that could be a big problem. How dare you ask me such a very useless question, in quote. People don't like to be asked such a thing. So we can use machine learning actually to analyze them. What is their behavior on social media? The way you chat with people, we look at history. We have data set in history, people with mental issue. These are some of the attributes of their chats on social media. Based on that, we can identify that this person is potentially likely to have this issue. So to me, this is some of the areas that actually machine learning can help. Area that medical doctor face a lot of issue, diagnosing the patient. You cannot just face somebody to ask them some very sensitive question. They get so irritated, even though they are suffering from that problem. If that irritation is a sign that they are solving that problem, but they will not agree. So we use silently, we monitor their behavior, their attributes, and we can actually be able to tell their parent, maybe their family relation, is the machine learning identify this person to have this possibly, we might need to start finding a way to reach out to that person. So I believe that a lot of application and a lot of work is going on in this area. So if it's an interest for someone, then it's a good place to pursue. Next, doctor. You can finish.
Okay. How can ML be used for a nonlinear system whose data can only be generated on closed loop and through feedback control system? Example is the multivariate interconnected tanks like quadruple tank system.
Okay. Well, like I said, just get the data. This is the simple thing. We should not look at the complication of those things because some of them might not be also very clear to us now. So just get the data ready and get an expert to talk to you. For sure, once the data is available, there will always be a way to get machine learning to work on them. Because systems that people thought that were not even possible before. Can you imagine now? Let me share an issue with you. Can you imagine that there is a system that predicts if someone is going to come late to work or is going to be absent? We call it absenteeism prediction. Imagine your boss call you at night. Hey, hello, Mr. B. We just want to tell you that please, we need you in the office tomorrow because we might be having a visitor. Usually you go to work every day. Why should he contact you and say, we need you at work? Because he has a system he already run that says that so worker might not come to work tomorrow and they seriously need you. He will reach out to you and he want to be polite. He might not tell you artificial intelligence says you're going to be absent, but there are systems already that are developed to predict who will come late and who will be absent, because they notice a lot of resources are being lost because of absenteeism of people. So that is to even say that even things that we thought that are not even possible, they are getting done with machine learning. So my advice is get the data set, get an appropriate expert to guide you to look at the data one-on-one. And I want to believe you'll be able to have a way to solve the problem using AI or any of the subfield. Next.
Number 8, this is number 8.
Okay.
ML application on the theft detection at work site.
Okay. Yeah, I think I've answered that question with the previous one. ML application can detect, depression. Actually, these are some of the systems we are ignoring, actually. And it's an area that personally I'm passionate about. Societal issues that should not be allowed to go unchecked. By monitoring people movements, the way they walk, the way they talk to people, a lot of data could be gathered. But for now, what people are using is the social media. They see the way they are chatting with their friends, the way they shout on people. A lot of things could be used to detect if it's a laborer, for example, is getting depressed or anybody is getting depressed. We don't need to wait for them to have that problem. Yeah. So theft detection. Oh, sorry. Yeah. So theft detection. Theft detection is also another area that actually can be a lot of work could be done in this area. So you just need to have the data. Behavior of people will be looked into. The nature of things that have been stolen in the place of work will be analyzed, and then data will be gathered. We'll now look at what are the data that are relevant. This is where you need experts to sit down with the client to now decide, oh, this data might work, this data might not work. But sometimes we use trial and error. Let's use this data, maybe it will work. Let's use another data, maybe it will not work. But for sure, once the data is available, machine learning can be tried for such thing. Next, doctor.
Okay, doctor. Now, this is number 9.
Okay.
How about reliability issue? Can the design be based reliability?
Reliability.
Yes.
Okay.
Reliability. Can a design be based on the predicted outputs of ML system where site-specific information is required? Where
site-specific information, eh?
Yes.
Yeah, thank you very much. Yeah, that is where the type of data you use to train is important. We call something heterogeneous prediction. This is where you want to use data from different sources to predict. It's very challenging, but we have Ensemble can solve that problem. It's another very advanced form of AI. So it can solve that particular kind of problem whereby heterogeneous data are being used. Ordinarily, you should use data from that side, maybe all data from that side to predict. Then you can extrapolate from to sides that are similar. But I have to tell you, it's very challenging if the sides are very difficult. What you can do is you can get a lot of machine learning algorithms together so that you have multiple, what we call multiple hypothesis function. I have algorithm A that has H2, another one A having H3. We match like maybe 250 machine learning algorithms. And anytime I want to make a prediction, they are going to cooperate to predict. And actually, this is one of the best areas machine learning is going. You want to really do complicated tasks, you need to combine several algorithms. Because no single algorithm will be able to solve that problem if it is really complicated. But we start from simple to the complicated. So you try simple algorithm. If it solves your problem, you have to have historic data. Once historic data is tested and it is correct, for sure, the new data will be fine. So, and we can also refer to some of our early videos on Ensemble, how to build it, and some of the advantages that are involved. Next, Doctor. Yeah.
Doctor, I think we have 19 questions. I'll just
19? It means the question keep coming. I thought 15, eh?
Yeah, can we just stop here?
Okay. Then we can call it a day here then. So
in fact, Doctor, there's a case I saw in social media. I mean, one YouTube, they talk about ML.
Okay.
How powerful it is.
Okay.
It said there's in the West, there's a mall that use ML. They use it to send promo code to their customers. When you buy things, you get your number and then they send promo code.
Yeah.
It happened that they sent a promo code to a girl, and the girl's about 14 or 15 years old.
Yeah.
To come and buy things that relate with pregnancy.
Okay.
The father was so furious.
Okay.
Went back to the mall. How dare you send this to my kid, my daughter? She's just in secondary school.
Yeah.
How can you buy things pregnant? A lot of commotion in the mall.
Yeah. Yeah.
Apologized to him and he left. Then 9 months later, or 10 months, he came back to apologize. The girl was actually pregnant, and the parents are not aware about it. But the mall, with the use of ML, they detected that she was pregnant because of things she come to buy from their mall. Hmm. I mean, that's how powerful this can be. We have to be clear of this.
Thank you very much, Doctor, actually. So, and thank you for the insight. Yeah, this is actually a very good kind of insight the doctor just provided. So from a little experience with this machine learning, really, I hope people can take positive side of it. There are going to be negative parts because there's nothing with positive without negative, just like any other system. It's like medical doctor. They are very important in society. But some of them will also do things that's really very good, very, very bad. Like the issue of abortions and the likes. Someone can decide to specialize in that, which, as we all know, the position of things. So anything could be abused. But I do hope people can take a lot of advantage from machine learning and what it portends. In my little experience, I've worked with a couple of people from different backgrounds. I mean, from different industry, research institution, and some of the problems that have been solved are things that ordinarily we thought were not possible. So the imagination keeps continuing, by the way. Like I said, some people develop machine learning stuff recently. The machine almost started speaking languages that they themselves cannot understand. I mean, things are really going, a lot of research are going on. So preemptive, what the doctor just mentioned is a preemptive identification. You see, someone already decided, they have designed things because they want to sell their pregnancy stuffs. They design things that can identify who is pregnant. By just looking at the face of someone, you might be able to know, which an average person will not pay attention to. The same way, if there's going to be a crime in a school, why no? Don't we have a kind of system that can tell us earlier that, oh, there might be some critical issue that might go on. So that's why, like I said, AI is not all about prediction, but a lot of things that recommendation. You want to recommend, oh, this might happen. Oh, this guy is here. Maybe something might go wrong there. So around so much area that we can look into. So I think it's good to call it a day.